All right, here we have the notes for section 4.3, which deals with circular functions. So we got the trig functions of any angle. So just some definitions. The beginning portion is referred to as the initial side. You rotate about the endpoint, which is referred to as the vertex. The final position is the terminal side. So here's your initial side, your vertex, and then your terminal side, and you rotate that way. So you're measuring your angle, that value. The measure of an angle is a number that describes the amount of rotation from the initial to the terminal side. So for example, this would be like about 30 degrees or something like that. Positive angles are generated by counterclockwise rotations. So this would be a positive angle. Negative angles are clockwise rotations. So if there's your initial side, you rotate that way. This would be, for example, like negative 30 degrees. Usually you place them in standard position, which means that your vertex lies at the origin and the initial side is on the positive x-axis. So two angles can have the same initial side and the same terminal side, yet have different measures. These are referred to as coterminal angles. So for example, there's my axes. If I draw this angle, that is 30 degrees positive, but it's also negative 330 degrees if I go the other way around. You could also turn around more than once. So remember, 360 degrees or 2 pi radian is a full rotation. So one rotation is 360 degrees or 2 pi radian. So it says find a positive and a negative angle that are coterminal. So to do that, you're just adding or subtracting full rotations, because you're gonna, as long as you add 360, you're just gonna end up back where you started. So for a positive, I would take 30 degrees plus 360, so 390 is a positive coterminal angle. For a negative, I would subtract 360, so that'd be negative 330 degrees. So 30, 390, and negative 330 all end up at the same place right here. On this picture, 390 would be if I rotate one full rotation, so there's 360 plus another 30. So negative 150, same thing. Negative 150 plus 360 is 210. Negative 150 minus 360 is negative 510 degrees, I think. Yep. The radians work the same way. So 2 pi over 3 plus 2 pi, 2 pi over 3 minus 2 pi. Now it may help to do common denominators. So this is 2 pi over 3 plus 6 pi over 3, so this is 8 pi over 3. This would be 2 pi over 3 minus 6 pi over 3. So this would be negative 4 pi over 3. So radians work the same way, except it's a little bit trickier because you need a common denominator. Okay, so example 2, let theta be the acute angle in standard position whose terminal side contains the point 5, 3. Find the 6 trig functions. So what you do is you draw, so 1, 2, 3, 4, 5, 1, 2, 3. So you have this point here, that's the terminal side. So we're actually just going to draw our triangle. So drop over. You always go horizontally on the x-axis. So this point, this side of the triangle is 3, the y value. This side of the triangle is 5. So to find the hypotenuse, Pythagorean theorem. 5 squared plus 3 squared equals c squared. 25 plus 9 is 3 squared, 34 is equal to c squared, so c is the square root of 34, which does not simplify. So then do the 6 trig functions. Well, we'll label this root 34. So sine is opposite over hypotenuse, so 3 over root 34, but you can't have the root on the bottom. Cosine is going to be adjacent, 5 over root 34, but you can't have the root on the bottom. And tangent is opposite over adjacent. And then there are reciprocal functions. So for cosecant, root 34 over 3, flip this guy. For secant, root 34 over 5, flip that guy. Cotangent, 5/3, flip that one. All right, so example 3, terminal side contains point negative 5, 3. So 1, 2, 3, 4, 5, 1, 2, 3. So my point's here. So this is negative 5, this is 3. Now I'm going to cheat. These are the same numbers before, so the hypotenuse is root 34. Whoops, that's in the wrong place. 1, 2, 3, 4, 5, 1, 2, 3. It's up here. This is still root 34 because it's still 25 plus 9. So the only difference is some of the functions are going to turn out to be negative. So sine theta, still 3 over root 34, or 3 root 34 over 34. Cosine, though, is going to be negative 5 over square root of 34. So it's now negative. Tangent, similar thing's going to happen. Opposite over adjacent is 3 over negative 5, or negative 3/5. So cotangent, flip it over, negative 5/3. Secant, flip it over, negative root 34 over 5. Cosecant, flip it over, root 34 over 3. So anything that involved the adjacent side, change sign. Now the adjacent's negative. The numerical part's all the same. All right, so here we have the definition of the trig functions of any angle. So that R denote the distance from the origin, which this equation is the Pythagoras, a squared plus b squared, and then take the square root. And then you have these definitions. So R is essentially the hypotenuse, y is the opposite side, x is the adjacent side, so on and so forth. So find the 6 trig functions of 315. So 315 degrees is down here. This angle is 45 degrees, which means that I have a 45, 45, 90 triangle. And for a 45, 45, 90, those are the measurements, 1, 1, root 2. It doesn't actually matter. You could do 2, 2, 2 root 2, but it's going to work out the same. So for sine, opposite of hypotenuse, 1 over root 2 is root 2 over 2. Cosine, oops, sine is going to be negative because this goes down. Cosine is going to be positive 1 over root 2, or positive root 2 over 2. Tangent is opposite over adjacent, negative 1 over 1, which is negative 1. So cotangent is the reciprocal of negative 1, which is just negative 1. Secant is the reciprocal, root 2. Cosecant is the reciprocal, negative root 2. So remember, for these two, flip these ones, the ones that are easier to do. All right, find the following without a calculator. So 210. So we actually need to sketch this first. So that's 90. 210 is over here. This is actually, that triangle is a 30, 60, 90, which means this is 1, 2, and root 3. Now that's negative because it's going left. So the sine is opposite over hypotenuse, so that is 1/2. 5 pi over 3 is down here. That is 60 degrees. So my triangle is 30, 60, 90 again. 1, 2, negative root 3. So opposite over adjacent is negative root 3. Secant, negative 3 pi over 4. So that's over here. So that's a 45, 45, 90. It's going to look like this. Secant is the reciprocal of the cosine, so I'm actually going to do cosine first. So cosine is adjacent. Oops, both negative. Adjacent over hypotenuse. And then I'm going to flip it over. So negative root 2 would be my answer. Or if you want to use the definitions up here, secant is the r value divided by the x value. So root 2 divided by negative 1 would give you negative root 2. Okay, so example 6, find each of the following if it exists. If the value is undefined, write undefined. So negative 270, that's 90, 180, so that's actually like this. So it's a vertical line straight up. So this r is the distance to the origin, and y is the y value. So this coordinate here, they're the same number. So that means the sine of negative 270 is just 1. It's just whatever that value is divided by itself. The tangent of 3 pi, so 3 pi is actually the same thing as 305. It's 1 full rotation and a half. So there's 2 pi plus 1 more. so it's straight over. So this triangle has no height, no y value, so tangent is equal to y over x, which is 0 over x, which in this case is just 0. The secant of 11 pi over 2, so let's make that into degrees. 11 divided by 2 times 180, so this is 990 degrees, so we'll make it a coterminal. So we'll just start subtracting 360s until it's what I need. So this is actually the same thing as 270 degrees, which is down here, 390s. So secant is the r value, which in this case is 1, divided by the x value, which in this case is 0. So this is undefined. There is no secant at 270 degrees. It cannot be solved. Okay, so for example 7, we've got find cosine theta and tangent theta using the given information to construct a reference triangle. So sine is 3/7 and the tangent's negative. So sine is 3/7 means that for my triangle, that's 3, that's 7. Now if the tangent is negative, this side actually should be negative, so my triangle is technically drawn wrong, but it's okay. So to find that missing side, 49 minus 9, square, square. So this is whatever root 40 is, which is 2 root 10. But negative means I need tangent to come out to be negative. So cosine theta for this problem is adjacent over hypotenuse, negative 2 root 10 over 7. Tangent is opposite over adjacent, so 3 over negative 2 root 10. Can't have the root on the bottom, so 3 root 10 over 20, negative. Okay, so if the secant is 3, now I'm going to cheat because secant and cosine are reciprocals, so cosine's 1/3. So if cosine's 1/3, 1/3. So find the missing side, that's going to be 9 minus 1 is 8, square root, so this side is 2 root 2. Sine's positive, so I leave it positive. So find cosine, well I already did cosine. So tangent is opposite over adjacent, so 2 root 2. Cotangent is undefined and the secant is negative. So cotangent is undefined and the secant being negative. So this means cosine is also negative. And this means the tangent is equal to 0. So that's actually over here. So cosine would be -1 because r and the x value are the same thing. R and x are both there. And then, oh, already got tangent. Tangent 0. Okay, real numbers. So it says the unit circle, the circle of radius 1 centered at the origin, which will come up later. So it just means that you have some circle. This distance here, whoops, is 1, and there's your angles going around. So that just refers to a unit circle. Unit meaning 1 unit. So trig functions for any real number. So let t be any real number. Let xy be the point corresponding to t when the number line is wrapped around a unit circle. So if you notice, all the r's disappeared, or r's turned into 1. That's because on the unit circle, the radius is defined to be 1. Periodic functions, a function is periodic if there's a positive number c, such that if you spin it around some amount, you get back to the same place. The smallest such number c is referred to as the period. So it's essentially a cycle of repeating values. So sine and cosine, the trig functions are periodic because their values repeat in a pattern. And the last thing we have is the actual picture of the unit circle, which will come in very handy. So here's your unit circle, radius 1, and then your angles in both degrees and radian. Now these ordered pairs are your xy values. Now because this is a unit circle, x squared plus y squared will equal 1 because that's the hypotenuse, which is the same thing as the radius. So if I take, for example, root 3 over 2 squared plus 1/2 squared, that should equal 1 squared, or 1, because 1 is the radius of the circle, and that's the hypotenuse of that right triangle. Now, the trick for the unit circle is these coordinates, if you drop your triangle in, they give you the y value and the x value. The radius on the unit circle is always 1, and that's true for any point you draw to. So there, this triangle has an x value of 1/2, a y value of -√3/2. Now, since on the unit circle, sine is y and cosine is x, the sine of 30 is 1/2, just the y value. The cosine of 30 is √3/2, the x value. Tangent is y divided by x, 1/2 divided by √3/2. But that's how you very briefly use the unit circle. And that, I believe, is the end of the section.